Hello everyone, and welcome to today's presentation. I'm excited to share with you our deep dive into RAG systems architecture. On this first slide, you'll see our main themes, from the basics of RAG systems, through their production architecture, and into their enterprise use cases. We'll explore how these systems make large language models smarter by integrating real knowledge through Retrieval Augmented Generation. Throughout this session, we'll take a technical deep dive to understand the core components and their applications. So, let's get started and uncover how RAG systems are transforming the way we work with AI. So, instead of retraining models from scratch each time, RAG takes a different approach by retrieving knowledge at runtime. This means it dynamically fetches relevant information from external sources, grounding the language model's responses in factual, up-to-date data. The core idea here is that knowledge is retrieved in real time to generate grounded responses, making the system much more current and accurate. Now, when you ask a question, the process involves the model retrieving relevant data, then using that information to craft a response. This is different from the traditional approach, where the language model relies solely on the training data it was originally fed. In that traditional setup, the model simply guesses based on what it learned during training, without access to the latest information. One of the key benefits of RAG is that it allows the model to access external sources like internal documents, proprietary knowledge, or private databases. These sources are invisible to the model when it's operating without RAG, which means it can provide much richer and more accurate answers. Another important point is that updating a standalone large language model's parameters requires massive computational resources, making frequent updates both costly and impractical. That's where RAG shines. It allows the model to stay current without needing expensive retraining. However, traditional models have their limitations. For example, they can sometimes generate plausible-sounding but factually incorrect information, a phenomenon known as hallucinations. This happens because models optimized for fluency might prioritize sounding good over accuracy. Plus, models trained on data up to a certain cutoff date have no awareness of recent events, market changes, or new research. This is called the knowledge cutoff. So, without RAG, these models are limited in their ability to provide the latest insights. In summary, RAG addresses these key limitations: outdated knowledge, high retraining costs, lack of access to private data, and hallucinations, by enabling models to retrieve relevant information at runtime, grounding their responses in current, factual data. Now, instead of guessing from memory, the LLM performs open-book reasoning. This means it references specific retrieved knowledge to generate answers that are not only accurate but also verifiable. The process begins with the user submitting a natural language question. Then, the system finds the most relevant document chunks by performing a similarity search on a vector database. These chunks are converted into numerical vectors through embeddings and split into manageable sections, like PDFs, policies, or articles. The model then processes the query along with this context, selecting the top K most relevant documents. This targeted approach allows the LLM to base its responses on retrieved facts, resulting in grounded answers. Essentially, this whole pipeline ensures that the information flowing from documents to the final answer is precise and reliable, making the system much more effective for real-world applications. Let's take a closer look at the vector DB, which plays a crucial role in our document ingestion process. First, we have the embedding step, where we convert text into vectors that capture the meaning of the content. Then, these vectors are chunked into manageable pieces, making it easier to search and retrieve relevant information. When it comes to document ingestion, the system automatically rewrites vague queries to improve retrieval accuracy. This means that even if a user's question isn't perfectly clear, the system can interpret and refine it for better results. Next is query processing, which is like auditioning documents. Only the most relevant chunks are presented to the language model. Think of it as selecting the best scenes from a movie to show the audience. Re-ranking then comes into play, where the system combines semantic understanding through vectors with exact matching via keywords. This hybrid approach ensures we get the most accurate and contextually relevant results possible. This hybrid search, merging vector and keyword techniques, enhances both precision and recall, giving us a powerful retrieval capability. Moving on to answer and validation, the language model generates responses, but it's also supported by a context builder that selects the best documents from the candidates. A re-ranking model further refines this selection by combining semantic and keyword matches. All of this is integrated into a hybrid retrieval process that involves query rewriting, expansion, and guardrails to ensure quality and safety. Finally, this entire pipeline, covering query processing, document retrieval, re-ranking, and validation, is part of our production pipeline. These advanced layers transform basic retrieval augmented generation systems into production-ready solutions, especially suited for enterprise systems where reliability and accuracy are paramount. Now, let's talk about the key principles for using RAG effectively. The main idea is to use RAG when the answer already exists within your documents or data sources. For example, if you're running SQL queries, making API calls, or performing CRUD operations, these are structured transactional queries and complex calculations that can be directly answered from existing data. This is where RAG really shines because it helps retrieve precise and relevant information efficiently. It's also ideal for tasks like mathematical problem solving, proofs, storytelling, poetry, marketing copy, or creative writing. Basically, when the task involves generating content based on known information or patterns, RAG can streamline the process. On the other hand, there are situations where you should avoid RAG. For example, legal and regulatory documents, contracts, compliance and legal retrieval, API documentation, architecture references, or developer documentation. These often require nuanced understanding and interpretation that might not be suited for straightforward retrieval. Similarly, customer support bots that answer questions from existing content, internal documentation, policies, procedures, or enterprise knowledge systems. These often demand more contextual understanding. So, when do you want to rely on RAG? When you're dealing with tasks that involve understanding and retrieving knowledge from structured data sources or existing content, RAG can maximize efficiency and accuracy. But for tasks requiring deep reasoning, interpretation, or creative and strategic thinking, it's better to look beyond RAG. In essence, knowing the sweet spot for RAG allows us to use it strategically, deploying it where it adds the most value, and avoiding it where human judgment or complex reasoning is needed. This balance helps us harness the full potential of our AI tools in a smart and effective way. All right, let's wrap up with a quick summary of what we've discussed. Without RAG, large language models rely solely on their memory, which can be limiting. But with Retrieval Augmented Generation, or RAG, they gain access to real, up-to-date knowledge, making them much more reliable for enterprise systems. This shift reduces those frustrating "let me check Stack Overflow" moments, because the system can directly fetch the relevant information. It also speeds up onboarding for new engineers, helping them get up to speed faster. Developers can now query internal APIs, microservices, and architecture documentation using natural language, and the system retrieves useful code examples, integration patterns, and best practices. Think of it as a developer co-pilot for internal systems, delivering consistent, accurate responses that resolve around 70% of Tier 1 inquiries. It pulls knowledge base articles, troubleshooting guides, and product documentation to answer customer questions instantly. For more complex issues, it escalates to human agents but provides the full context to make their job easier. On the customer support side, it offers 24/7 self-service access, reducing document search time by up to 80%. Employees can ask natural language questions across all internal documentation, and the system finds relevant policies, procedures, or past decisions, then generates comprehensive answers with source citations. All these examples demonstrate how RAG-enabled systems are transforming organizations, delivering real-world impact by making internal operations more efficient, accurate, and responsive.